Hello and welcome back to another Siemens S7-1200 and Factory I/O tutorial, as well as the Arduino. Today we'll be programming the PLC to make use of the value we read from the Arduino's input register, and then we'll use that value as a set point to control the water level in Factory I/O water tank. So stay tuned. Welcome back. So this is where we were at the end of the previous video, where the PLC client was able to read an input register in the Arduino via Modbus, which was set by the potentiometer. And in this video we will be using the value read by the PLC to set the required water level in the tank. So let's make a start. Now the value set by the potentiometer and stored in the Arduino's input register was between 0 and 1023. And we have to take that value and use the NormX, ScaleX and ConvertX instructions to get the value between 0 and 300 centimeters for the Factory I/O water tank we're using. But first I'm going to move the value from the Modbus PTR data block and put it into a double integer in the PLC. So let's go to the top of the main OB1 and insert a new network, which will be network 2. Let's go offline so it doesn't look as though we have errors and clears up the screen a bit. Now under basic instructions, open up the move operations and drag the move instruction into network 2. Right, let's give ourselves a little bit more screen space for the TI portal. Then open up the Modbus PTR data block and then split the screen to show both the Modbus PTR DB and network 2 in main OB1 at the same time. Now let's place data onto the in on the move instruction and let go. Now for the output, we add a tag name first, and I'm going to call it Arduino value and change the data type to a double integer. And for the address, we will use MD116, which is the next available. Right, let's change back to the ladder network, main OB1, and select Arduino value for the output on move in network 2. So now the potentiometer value will be moved to MD116, and we can now use this value in NormX. So let's go to the setPoint function we set up in the part 2 video. The link to this video is in the description below. Now we need to change setPoint to Arduino value and set the max variable to 1023 so that NormX will work out the value between 0 and 1 for the potentiometer value and place it in temp 2. A potentiometer value of 1023 will compute to 1. And a potentiometer value of 0 will compute to 0. Therefore, a potentiometer value of 512 will compute to approximately 0.5. ScaleX is already set between 0 and 300, so that is fine. So let's go back to main OB1 and download the updated code to the PLC. OK, load, and finish. Right, let's restore the active window and make some room on screen for Factory I/O. I'll minimize the Arduino serial monitor. That looks fine. Now let's start up Factory I/O and let's open the Part 2 water tank scene which we used in the Part 2 video. That's fine. Now let's connect Factory I/O with the PLC via drivers, then connect. We have the green tick, so we are connected. Let's go back to the main screen and play Factory I/O. Okay, we are ready. Now let's start the PLC and we are now in monitoring mode. The tank is starting to fill, so we must have had a value set by the potentiometer already. So let's rotate it down to 0, then drain the tank. I'll change the format of the Modbus PTR to decimal from hex. That's good. Now we are finally ready to test the potentiometer as a set point. So let's rotate the potentiometer clockwise. We can see a reading of 423 read from the Arduino. Let's rotate the potentiometer a little bit more to roughly halfway, and the tank starts to fill up to the set point value, which is calculated and shown on the Factory I/O display. And the tank fill valve closes as soon as the set point value is reached. Now let's just take a look at the set point calculations before I drain some water to see if the tank will refill automatically back to the set point level. So we can see the Arduino value read, which is 530. The norm X calculates 530 divided by 1023 to equal 0.518 and places that value in temp 2. Then ScaleX uses the value in temp 2 and multiplies it by 300 to give 155.425. The last instruction then converts this value to an integer which works out to be 155, which is displayed on the Factory I/O LCD display on the control panel. The actual value in the tank is just below 165 because the valve took time to close once the set point had been reached. Right, let's just drain some water and see what happens. As soon as the water level is below the set point value, the fill valve opens to try and maintain the set point water level in the tank. Now I'm just going to reduce the set point value by rotating the potentiometer anti-clockwise. 102 should be fine. Now let's drain the tank and see what happens. Now if we divide 102 by 1023, we get 0.997. Then multiply that by 300 and we get 29.9, approximately 30. So the fill valve should open as soon as we get below a water level of 30 centimeters. Let's see. And it does. Great. I'll just turn the potentiometer upwards again. I could actually play with this all day. Great. Well, that all seems to be working. So thanks for watching. Hope you've enjoyed it. And in the next video we will implement closed-loop proportional control. Until then, if you would like to learn more, then please click the subscribe button and the bell so you'll be informed as soon as a new video is uploaded. Please see the links in the description should you wish to get a free 30-day license of Factory I/O, and also check out my Patreon account. And I'll see you in the next video. So bye for now.